No, of course not. I mean, I think that in the kind of medium term by AI timescale anyway, there will be an ecosystem. There will be different uses for different model sizes. There will be plenty of people who are very excited, for whom the best 7B model is good enough. They'll be very happy with it. And then there'll be plenty of very, very exciting and amazing applications for which it won't be enough. I think that's all. I mean, I think the big models will be better than the small models, but not all applications will justify the cost of a large model.
What do you think the role of open source is in this ecosystem?
Well, open source is complicated. I'll describe to you my mental picture. I think that in the near term, open source is just helping companies produce useful, let's see. Why would one want to have an open source, to use an open source model instead of a closed source model that's hosted by some other company? I mean, I think it's very valid to want to be the final decider on the exact way in which you want your model to be used, and for you to make the decision of exactly how you want the model to be used and which use case you wish to support. And I think there's going to be a lot of demand for open source models. And I think there will be quite a few companies that will use them. And I'd imagine that will be the case in the near term. I would say in the long run, I think the situation with open source models will become more complicated. And I'm not sure what the right answer is there. Right now, it's a little bit difficult to imagine. So we need to put our future hat, maybe futurist hat. It's not too hard to get into a sci-fi mode when you remember that we are talking to computers and they understand us. But so far, these models actually not very competent. They can't do tasks at all. I do think that there will come a day where the level of capability of models will be very high. Like in the end of the day, intelligence is power, right? Right now, these models, their main impact, I would say, at least popular impact, has been primarily around entertainment and like simple question answer. So you talk to a model, wow, this is so cool. You produce some images, you had a conversation, maybe you had some question, you got answered. But it's very different from completing some large and complicated task like, well, what about if you had a model which could autonomously start and build a large tech company? I think if these models were open source, they would have a difficult to predict consequence. Like we are quite far from these models right now. And by quite far, I mean by AI timescale, but still like, this is not what we're talking about. But the day will come when you have models which can do science autonomously, like deliver on big science projects. And it becomes more complicated as to whether it is desirable that models of such power should be open sourced. I think the argument there is a lot less clear-cut, a lot less straightforward compared to the current level models, which are very useful. And I think it's fantastic that the current level models have been built. So like that is maybe I answered a slightly bigger question rather than what is the role of open source models. It's like, what's the deal with open source? And the deal is up to a certain capability. It's great, but not difficult to imagine models sufficiently powerful, which will be built, where it becomes a lot less obvious as to the benefits of their open source.
Is there a signal for you that we've reached that level or that we're approaching it? Like what's the boundary?
So I think figuring out this boundary very well is an urgent research project. I think one of the things that help is that the closed source models are more capable than the open source models. So the closed source models could be studied and so on. And so you'd have some experience with a generation of closed source model. And then you know, like, oh, these models' capabilities, it's fine. There's no big deal there. Then in like a couple of years, the open source models catch up. And maybe a day will come when we're going to say, well, like these closed source models, they're getting a little too drastic. And then some other approach is needed.
If we have our, future hat on, maybe let's like think about like a several year timeline. What are the limits you see, if any, in the near term in scaling? Is it like data, token scarcity, cost of compute, architectural issues?
So the most near term limit to scaling is obviously data. This is well known. And Some research is required to address it. Without going into the details, I'll just say that the data limit can be overcome and progress will continue.
One question I've heard people debate a little bit is the degree to which the transformer-based models can be applied to sort of the full set of areas that you'd need for AGI. And if you look at the human brain, for example, you do have reasonably specialized systems. They're all neural networks, but you have specialized systems for the visual cortex versus, areas of higher thought, areas for empathy, or other sort of aspects of everything from personality to processing. Do you think that the transformer architectures are the main thing that will just keep going and get us there? Or do you think we'll need other architectures over time?
So I understand precisely what you're saying, and I have two answers to this question. The first is that, in my opinion, the best way to think about the question of architecture is not in terms of a binary, is it enough, but how much effort, what will be the cost of using this particular architecture. Like at this point, I don't think anyone doubts that the transformer architecture can do amazing things, but maybe something else, maybe some modification could have some compute efficiency benefits. So it's better to think about it in terms of compute efficiency rather than in terms of can it get there at all. I think at this point, the answer is obviously yes. To the question about, what about the human brain and with its brain regions? I actually think that the situation there is subtle and deceptive for the following reason. So what I believe you alluded to is the fact that the human brain has known regions. It has a speech perception region, it has a speech production region, it has an image region, it has a face region, it has all these regions. And it looks like it's specialized. But you know what's interesting? Sometimes there are cases where very young children have severe cases of epilepsy at a young age. And the only way they figured out how to treat such children is by removing half of their brain. Because it happened at such a young age, these children grow up to be pretty functional adults. And they have all the same brain regions, but they are somehow compressed onto one hemisphere. So maybe some, information processing efficiency is lost. It's a very traumatic thing to experience, but somehow all these brain regions rearrange themselves. There is another experiment which was done maybe 30 or 40 years ago on ferrets. So the ferret is a small animal. It's a pretty mean experiment. They took the optic nerve of the ferret, which comes from its eye, and attached it to its auditory cortex. So now the inputs from the eye starts to map to the speech processing area of the brain. And then they recorded different neurons after it had a few days of learning to see, and they found neurons in the auditory cortex, which were very similar to the visual cortex. Or vice versa. It was either they mapped the eye to the ear, to the auditory cortex, or the ear to the visual cortex. But something like this has happened. These are fairly well-known ideas in AI that the cortex of humans and animals are extremely uniform. And so that further supports you just need one big uniform architecture. That's all you need.
Yeah, in general, it seems like every biological system is reasonably lazy in terms of taking one system and then reproducing it and then reusing it in different ways. And that's true of everything from DNA encoding. There's 20 amino acids in protein sequences. And so everything is made out of the same 20 amino acids on through to your point, sort of how you think about tissue architecture. So it's remarkable that carries over into the digital world as well, depending on the architecture you use.
I mean, the way I see it is that this is an indication that from a technological point of view, we are very much on the right track, because you have all these interesting analogies between human intelligence and biological intelligence and artificial intelligence. We've got artificial neurons, biological neurons, unified brain architecture for biological intelligence, unified neural network architecture for artificial intelligence.
At what point do you think we should start thinking about these systems as digital life?
I can answer that question. I think that will happen when those systems become reliable in such a way as to be very autonomous. Right now, those systems are clearly not autonomous. They're inching there, but they're not. And that makes them a lot less useful too, because you can't ask it, hey, do my homework or do my taxes, or you see what I mean? So the usefulness is greatly limited. As the usefulness increases, they will indeed become more like artificial life, which also makes it more, I would argue, trepidatious, right? If you imagine actual artificial life with brains that are smarter than humans, gosh, that seems pretty monumental.
Why is your definition based on autonomy? Because, if you often look at the definition of biological life, it has to do with reproductive capability. Plus, I guess some form of autonomy, right? Like a virus isn't really necessarily considered alive much of the time, right? But a bacteria is. And you could imagine situations where you have symbiotic relationships or other things where something can't really quite function autonomously, but it's still considered a life form. So I'm a little bit curious about autonomy being the definition versus some of these other aspects.
Well, I mean, definitions are chosen for our convenience, and it's a matter of debate. In my opinion, technology already has the reproductive function, right? And if you look at, for example, I don't know if you've seen those images of the evolution of cell phones and then smartphones over the past 25 years. You got this like what almost looks like an evolutionary tree, or the evolution of cars over the past century. So technology is already reproducing using the minds of people who copy ideas from previous generation of technology. So I claim that the reproduction is already there. The autonomy piece, I claim, is not. And indeed, I also agree that there is no autonomous reproduction. But that would be like, can you imagine if you have like autonomously reproducing AIs? I actually think that that is a pretty dramatic and I would say quite a scary thing if you have an autonomously reproducing AI, if it's also very capable.
Should we talk about super alignment?
Yeah, very much so.
Can you just sort of define it? And then, we were talking about what the boundary is for when you feel we need to begin to worry about these capabilities being in open source. Like, what is super alignment, and like why invest in it now?
The answer to your question really depends to where you think AI is headed. If you just try to imagine and look into the future, which is of course a very difficult thing to do, but let's try to do it anyway. Where do we think things will be in 5 years or in 10 years? I mean, progress has been really stunning over the past few years. Maybe it will be a little bit slower, but still, if you extrapolate this kind of progress, we'll be in a very, very different place in 5 years, let alone 10 years. It doesn't seem implausible. It doesn't seem at all implausible that we will have computers, data centers that are much smarter than people. And by smarter, I don't mean just have more memory or have more knowledge, but I also mean have deeper insight into the same subjects that we people are studying and looking into. It means learn even faster than people. Like, what could such AIs do? I don't know. Certainly, if such an AI were the basis of some artificial life, it would be, well, how do you even think about it? If you have some very powerful data center that's also alive, in a sense, that's what we're talking about. And when I imagine this world, my reaction is, gosh, this is very unpredictable what's going to happen. Very unpredictable. But there is a bare minimum which we can articulate. That if such very, very intelligent, super intelligent data centers are being built at all, we want those data centers to hold warm and positive feelings towards people, towards humanity. Because this is going to be non-human life, in a sense. Potentially, it could be potentially be that. And so I would want that any instance of such super intelligence, the warm feelings towards humanity. And so this is what we are doing with the Super Alignment Project. We are saying, hey, if you just allow yourself, if you just accept that the progress that we've seen, maybe it will be slower, but it will continue. If you allow yourself that, then can you start doing productive work today to build the science so that we will be able to handle the problem of controlling such future superintelligence, of imprinting onto them a strong desire to be nice and kind to people. Because those data centers, right, they'll be really quite powerful. There'll probably be many of them. The world will be very complicated, but somehow, to the extent that they are autonomous, to the extent that they are agents, to the extent they are beings, I want them to be pro-social, pro-human social. That's the goal.
What do you think is the likelihood of that goal? I mean, some of it feels like a outcome you can hopefully affect, right? But are we likely to have pro-social AIs that we are friends with individually or, as a species?
Well, I mean, friends with, I think that part is not necessary. The friendship piece, I think, is optional, but I do think that we want to have very prosocial AI. I think it's possible. I don't think it's guaranteed, but I think it's possible. I think it's going to be possible, and the possibility of that will increase insofar as more and more people allow themselves to look into the future, into the 5 to 10 year future, and just ask yourself, what do you expect AI to be able to do then? How capable do you expect it to be then? And I think that with each passing year, if indeed AI continues to improve, and as people get to experience, because right now we are talking, making arguments, but if you actually get to experience, oh gosh, the AI from last year, which was really helpful, this year it puts the previous one to shame, and you go, okay. And then 1 year later, and 1 year, it's starting to do science. The AI software engineer is starting to get really quite good, let's say. I think that will create a lot more desire in people for what you just described, for the future superintelligence to indeed be very prosocial. I think there's going to be a lot of disagreement, there's going to be a lot of political questions, but I think that as people see AI actually getting better, as people experience it, the desire for the prosocial superintelligence, the humanity-loving superintelligence, as much as as much as it can be done, will increase. And on the scientific problem, I think right now it's still being an area where not that many people are working on. Our AIs are getting powerful enough where you can really start studying it productively. We'll have some very exciting research to share soon. But I would say that's the big picture situation here. It really boils down to look at what you've experienced with AI up until now. Ask yourself, is it slowing down? Will it slow down next year? We will see, and we'll experience it again and again. And I think it will keep and what needs to be done will keep becoming clearer.
Do you think we're just on an accelerative path? Because I think fundamentally, if you look at certain technology waves, they tend to inflect and then accelerate versus decelerate. And so it really feels like we're in an acceleration phase right now versus the deceleration phase.
Yeah. I mean, we are, right now, it is indeed the case that we are in an acceleration phase. It's hard to say, multiple forces will come into play. Some forces are accelerating forces and some forces are decelerating. So for example, the cost and scale are a decelerating force. The fact that our data is finite is a decelerating force. To some degree, at least. I don't want to overstate.
Yeah, it's kind of within an asymptote, right? At some point you hit it, but when it's the standard S-curve, right, or sigmoidal.
Well, with the data in particular, I just think it just won't be an issue because we'll figure out something else. But then you might argue the size of the engineering project is a decelerating force, just the complexity of management. On the other hand, the amount of investment is an accelerating force. The amount of interest from people, from engineers, scientists is an accelerating force. And I think there is one other accelerating force. And that is the fact that biological evolution has been able to figure it out. And the fact that up until now, progress in AI has had, up until this point, this weird property that it's kind of been, it's been very hard to execute on. But in some sense, it's also been more straightforward than one would have expected, perhaps. In some sense, I don't know much physics, but my understanding is that if you want to make progress in quantum physics or something, you need to be really intelligent and spend many years in grad school studying how these things work. Whereas with AI, you have people come in, get up to speed quickly, start making contributions quickly. It has the flavor is somehow different. Somehow it's very... there's a lot of give to this particular area of research. And I think this is also an accelerating force. How will it all play out remains to be seen. It may be that somehow the scale required, the engineering complexity will start to make it so that the rate of progress will start to slow down. It will still continue, but maybe not as quick as we had before. Or maybe the forces which are coming together to push it will be such that it will be as fast for maybe a few more years before it will start to slow down. If at all. That would be my articulation here.
Ilya, this has been a great conversation.
Thanks for joining us.
Thank you so much for the conversation. I really enjoyed it.